Hi everybody, I am your Prasad. Today we are going to discuss Dijkstra algorithm. Here J is silent. Dijkstra algorithm. Dijkstra is the scientist name for single source shortest path problem. This is the extension video of my previous video, that is single source shortest path problem. This is a topic from 4th unit greedy method. Greedy method, one of the technique or method to design algorithm from the subject design and analysis of algorithm. Right? Before going to that, we need to know some basic things. Here, vertices means these nodes are nothing but cities in real time. When we design Google mapping, for that we will write this algorithm, then we will type Java programs, then we will design shortest path to Google Maps distances. Right? Whereas these weights, these edges are nothing but distance, length, or sometimes cost, price, and sometimes time also. Right? In Indian units, distance means kilometers, cost price means rupees, whereas in US dollars, and whereas time hours. For knowing this, we will go with a small diagram. For example, imagine a directed graph, means directions, arrow marks are given like this, 1 to 2. 1 city to 2 city, the weight or the distance is 20. And we need to find there are any other distances which are shortest way, shortest path. Via 3, we can go via 3 to 2 city. 1 to 3, the distance is 10, and 3 to 2, the distance is 5. So 1 to 2, the actual distance is 20. This is direct way. So we need to find other path. Like, we'll write with other marker. 1 to 3, 1 to 3, and 3 to 2. You can go like that also. 1 to 3, the distance is 10, plus 3 to 2, the distance is 5. Total we have 15. This is the shortest distance from 20. If you want to see the full description, you can see my previous video. I will put in my card, and I will put in my description link also. And at the end of my video also, I will attach the video. This is previous video's diagram from the textbook itself. See, 1, 2, 3, 4, 5, 6. These are nodes or vertices. In real time, those are cities. Right? This is also directed graph because directions have been given. So we need to find out the shortest distance from single source, means single node, from single city to we need to find out shortest path distance from all other cities. Right? Here we have taken as 1. So this is basic thing. Now we'll go with the algorithm. So algorithm, the definition is a step-by-step English representation of a program. Step 1, write with black pen in your exam and write this description in blue pen, and write the description also, explanation for this algorithm, like what are these variables, then you will get full marks. Step 1, start. Step 2, what is the question given, write that only. Algorithm for shortest path. These are variables here, v, cost, distance, and n. V is a vertex node, for example 1 or something else. Cost means price, length, distance, and n is number of vertices. Here in this scenario, in this example, number of vertices are 6, number of nodes are 6, maximum cities, maximum nodes in this example. Second, step 2 is the question. Step 3, distance, these are comments. Distance j, j is one more node, something else, one more node that lies in between, that will be there in between this. One is j is greater than or equal to 1, that is starting to, and n is the last vertices. The j lies in between 1 and n, means 1 is this vertices, n is 6, in between that any vertex, imagine. In the length of the shortest path, we need to find shortest path, shortest distance, shortest way. Step 4, from vertex v, some vertices v to vertex j, any other vertices. Variables, here v, I, j, these are example variables for showing vertices in a graph G. G is a graph, directed graph. V comma E. G is a directed graph, digraph. V means vertices, E means edges. N means number of vertices, right, with N vertices. Select the shortest node. We need to find a shortest node from all other nodes. Shortest distance from single source. Then here curly braces will start in step 6. Step 7, for I equal to 1 to n2. We need to repeat from 1 to n. We need to find all distances, that to shortest. Find the shortest path. We need to find the shortest way, shortest distance to all other nodes. From the source node, source city, that is nothing but single source. From the single node. You watch my videos in horizontal mode of your mobile phone and zoom a little bit. You can see the text font, more font, and kindly use earphones for better voice clarity. Right? Here curly braces start if a condition will be given. If distance W, I will put a box so that it will be visible. Distance W is one more vertex, is greater than distance V plus cost V comma W. For example, in this scenario, for example, distance W, this one, right? Distance W is equal to 20 from source node. This is the single source node. W distance is 20. So we need to find if it is greater. If it is greater, we need to take shortest distance. Other way, we need to find any other ways are there which are shortest length. Distance V. Distance V, that is here 10, and cost V comma W. V comma W, that is cost V comma W, that is 5. That is 5. So your total distance is 15. So this is small one. So here in this condition, distance W is 20. That is greater than this 10 and 5. This is 15. This is 15. So we need to take this one. So instead of distance W, here distance W, we need to take distance via distance V plus cost V comma W. We need to take this one. This one. Instead of 1 to 2, direct distance is there, direct path is there, but that is more distance, 20. So we need to go via 3 to 2. That is less distance, 15. Right? So this is the answer. Like that we need to find all nodes from 1 to n. From 1 to n, 6. Like that we need to find the shortest distance. For this is close here. For this is close here. And stop. Last step is stop. Right? Write neatly in the exam. Use black pen and blue pen. And write the description of this. Right? With complete 2-3 pages, you will get good marks. All the best.